It's exciting to come your way once again as we continue this wonderful journey in core mathematics. My name is Nana Yawedu, and you can call me Sir Nana. In our previous lesson, we have considered how we can find the magnitude of a vector, where we realize that the magnitude simply refers to the length of a line of a vector. Remember to like this video, share this video, comment at the comment section, click on the notification bell and subscribe to my YouTube channel so that you can get all the videos on time. In this lesson, we want to consider the types of vectors that we have, and we will focus on the equal vectors. So now let's look at what an equal vector is. So basically, when we look at the equal vector, we are considering having two vectors. So let's consider that we have a vector AB, right? And then we have a vector XY. If we say that these two vectors have the same magnitude, where we know the magnitude represents the length, and then these two vectors have the same direction, where direction represents the displacement, then we say that the vector AB and XY are equal. So we say that vectors have same magnitude and direction, then it means that those vectors are equal vectors. Now let's consider the diagram that we have here. There are some vectors that have been indicated in the grid, right? So we have a vector P to Q based on the direction. We have a vector from R to X. We have a vector from A to B, right? So it moves from A to B. We have a vector from T to U, right? And then we have a vector from X to Y. Now, when we consider all of them, we realize that all the vectors have the same magnitude, right? So they have the same magnitude. You could see that the length moves from one grid to the second grid. So probably let's say 2 units. So this is 2 units. This is also 2 units. This is also 2 units. And then this as well is in 2 units. But then when we consider the directions, we see that PQ, RS, right, TU, and then XY is in the same direction. I hope you've seen it. And then when we take AB, AB moves in a different direction from the other directions, right? So PQ is moving in one direction, and then AB is moving in the opposite direction. So we can say that the vector PQ, right, NRS, NTU, and then XY are equal vectors, right? Because for vector PQ, RS, T, and then U, and then X and Y, they all move in the same direction, and then they have the same magnitude, right? But then for BA, even though it has the same magnitude, it moves in a different direction. So basically, when we consider the magnitude of a vector, as we looked at in the previous lesson, we've mentioned that for magnitude, it refers to the length, right? So for magnitude of AB, we are considering the length, right? So two vectors have the same magnitude if they have the same length. So if we say vector AB, right, has the same length as vector XY, then it means that their magnitudes are the same, right? And then their lengths are the same. So if AB is equal to 5 centimeters, then it implies that X to Y would also be equal to 5 centimeters in terms of the length, right? But then the direction of a vector refers to the line along which it points. So does it point in this direction or it points to the opposite direction, right? So two vectors having the same direction are parallel. So if you have two vectors, for instance, you have a vector from A to B, right, pointing towards this direction, and then you have a vector from X to Y pointing towards this direction, then it means that from A to B and then X to Y as vectors are equidistant to each other, right? It means that AB is parallel to XY, right? So from X to Y, then AB, they are parallel. So that is what it implies. Once they have the same direction, then they are parallel to each other. Now let's consider an example so that we'll be able to visualize it well. Now consider two displacement vectors, right? So two vectors in a coordinate system. If vector A represents a displacement of 10 meters to the south, right? So for instance, let's consider that this is in the coordinate system, and then the vector A is here, and it is at the point here. It moves towards the south, right? So our south moves downward this way, so towards our south, right? It moves 10 meters, and then it moves towards our south, and that is our vector A, right? And then vector B also represents a displacement of 10 meters. So same magnitude, right? So it means that vector B also moves from this side, right, towards the south here, same magnitude. And then they have the same magnitude, right, as 10 meters. And then it also moves south, right? So there's no difference between the vector A that has a magnitude of 10 meters and then the direction moving south, and then vector B that has a magnitude of 10 meters and the direction moving south. So we can say that vector A, right, is equal to vector B because they have the same magnitude and then they have the same direction. So basically in this lesson we have considered equal vectors, and we mentioned that for equal vectors they have the same magnitude and then they also have the same direction. In our next lesson, we'll consider some other types of vectors, such as the unit vector, the zero vector, and then the position vector. Remember to like this video, share this video, and subscribe to my YouTube channel. See you in the next lesson.